So I posted another video on Google Classroom that goes through problems 3 and 5, so I'm not going to go back through those. I still left my work on my worksheet here, so you can take a look at that if you like, but we're going to go through the rest of these problems. So in this part 2 of factoring polynomials, when a is greater than 1, so again, a is that leading coefficient. Here's a, there's b, and there's c. So a is 16, b is negative 4, and c is negative 20. So all of these are in the form ax squared plus bx plus c. Okay, so to factor them, remember, in order to factor a trinomial, it has to be written as the product of two binomials. So I wrote my steps on here for number 3. The first thing we need to do on every single problem is factor out the greatest common factor if one exists. And that's always going to be the case when you are factoring. You always want to try to take out a greatest common factor. If you don't, your answers will have a greatest common factor still in your factors, and that's not factored completely. So we always want to take out that greatest common factor right away. So the greatest common factor is the number that all three terms are divisible by. To be divisible by means when you divide it by that value, you get a whole number. So what are 16, 4, and 20 all divisible by? Well, 4 is the largest number that they're all divisible by. Now, I did an example on number 5. I said, well, let's say you can't think of the greatest common factor, so you notice that they're all even, so you take out a 2. And then I went through the process of if you try to take out a 2, well, then you still have a greatest common factor, and you can take out another 2, which multiplies to give you a 4. So if you don't take out the greatest common factor, if you just take out some common factor, you still have a common factor within your terms. So just watch out for that. So step 1, factor out the greatest common factor. In this case is 4. And then what remains after factoring out a 4? So what would I have to multiply 4 by to get that first term back? So 4 times 4k squared would give me a 16k squared. 4 times what would give me a negative 4k, and that's a negative k. 4 times negative k is negative 4k. And 4 times what gives me negative 20, and that's negative 5. 4 times negative 5 is negative 20. So I could redistribute this 4 back in and get what I started with. That's what it means to factor out the 4. You're dividing out 4 from each 3 of the terms. Okay, now that we have a trinomial with no greatest common factors, we are able to factor the trinomial. So, as I said earlier, a trinomial is factorable if it can be written as the product of two binomials. And now we need to figure out what would go in those 4 positions. And that's where all the different possibilities come in. So on this one, you can try different possibilities like 4k here and 1k here. The reason I'm putting k's in the first position is because think of how we multiply binomials. We use the acronym FOIL, which stands for first, outside, inside, last. So first, the first 2 that get multiplied together, that would give me the 4k squared. The last 2 that get multiplied together need to give me the negative 5. So I'm going to try a positive 1 and a negative 5. It either has to be a positive 1 and a negative 5, or a negative 1 and a positive 5, and then I could also try to flip-flop those. So that is one thing that could change. I also could try a 2k here and a 2k there. So there are a lot of possibilities. Let's just see if I happen to get this right on the first case of possibilities. So here's how I'm going to double check. I'm going to FOIL it. First outside, inside, last. I'm going to FOIL this together and see if it gives me that trinomial. So 4k times k, I'll just make a little note over here. 4k times k gives me 4k squared. 4k times negative 5 gives me a negative 20k. The inside 2, when multiplied together, the inside 2 terms gives me a positive k, so plus k. And the last 2 give me a 1 times negative 5 is negative 5. Well, if you multiply, so again, first outside, inside, last, we get 4k squared minus 20k plus k minus 5. We get this trinomial. Combine those 2 middle terms, the like terms, we get 4k squared minus 19k minus 5. Is that the trinomial that we started with? And in fact, no, it is not. So this is not the correct factored form. So that was just one possible case, but this one is no good. So we need to try another one. So because I tried 4k plus 1 and k minus 5, I still have another option with 4k remaining in that first spot and then k remaining in the first spot of the other binomial. So I can try the 4 out. Well, the 4 has to stay out in front. I can try the 4k in the first position. I can try the k in the other first position. And then instead of putting plus 1 and minus 5, I could try minus 5 here and plus 1 there. Again, those last two just have to multiply to give me a negative 5. The first two have to multiply to give me a 4k squared. The rest of this, the middle term, comes from when you multiply the outside and the inside together, and then you add those like terms together. So we have to see if we multiply the outside and inside and then combine them together, do we get that middle term of negative 4k? In this one, we did not. So let's check. If I multiply the first two together, I get 4k squared. The outside 2, I get 4k. The inside 2, a negative 5k. And the last two, that negative 5. Combining the like terms in the middle, I get 4k squared minus k. 4k minus 5k is a negative 1k, or just negative k. And then the minus 5 on the end. Well, this is that trinomial that I had started with. So this is the factored form, because when I multiply them back together, I get that previous step. So this is the factored form. This is the answer to number 1. All right, so I'm going to start speeding up little by little on each of these questions. I'm going to start not explaining everything as in depth, because I explained 3 and 5 in depth. Now I explained 1 in depth. So I'm going to try to start speeding up a little bit. All right, so number 2, first thing again, look for the greatest common factor. So you have to think of, what is 24 divisible by? So it's even, so definitely 2. All of these are even, so I know I can at least divide out a 2 or factor out a 2. But is there anything bigger? So you could try 3. So 24 divided by 3 is 8. And if you need to, you can take out a calculator. It's okay to take out a calculator and do 24 divided by 3. Is it divisible by 3? Yes. Is 90 divided by 3? Yes. Divisible by 3? Yes. Is 54 divisible by 3? Yes. So it could be a 3. So I might need to write a 3 out here, but is there anything even bigger? So 24 is also divisible by, if you're not sure, you could try 4. It gives me a 6. But is 90 divisible by 4? Oh no, so that doesn't work. I didn't get a whole number. You could try 5, but is 24 divisible by 5? Hopefully you're saying no, because it's not ending in a 5 or a 0. What about 6? Is 24 divisible by 6? Yes. Is 90 divisible by 6? Yes. Oops, I typed 60, which is also divisible by 6. But is 90 divisible by 6? Yes. And is 54 divisible by 6? That's also a yes. So 6 goes into it. Does anything bigger go into 24 that might go into the other two? You could try 8. 12 or 24. So if you try 8, is 90 divisible by 8? Nope. 12, 90 divisible by 12? No. And then 24 is 90 divisible by 24? No. So the greatest common factor of all these numbers is going to be 6. Now I need to factor that trinomial that remains. Oops, I need to put one more step on here. All right, so what remains when I factor out the 6? So I have 6 times what gives me this first term, and that's a 4x squared. 6 times what gives me 90x, and that's a 15x. 6 times what gives me 54, and that's a 9. And now I've got my trinomial, so I'm going to factor this trinomial. So I have 6 times 2 binomials. The first position has to multiply, the first two positions have to multiply the 4x squared and the last two to positive 9. So I'm just going to try one possibility. I'm going to try 4x in the first position here. Then I need another x over there to multiply to 4x squared when I multiply the first two together. The last two need to multiply to 9, so I'm just going to try 3 and 3. And like I said, the more you practice these, the faster you're going to get. You're going to start to think, okay, multiply here, that's 4x squared, there's 9. The outside is 12x, the inside is 3x. Oh, that adds to 15x. So that's the factored form. So you can start to do all this work in your head. You can try different possibilities in your head, and you'll get there. It just takes a lot of practice. Some of you are sitting there going, I can't even get to that first step. That's okay. Keep practicing. Keep watching these videos. There's a lot of resources online as well. Some of you, I can tell, are looking at other resources because the methods you are using to factor are different. And that's okay, but I was actually, it was requested by the other math teachers that I teach factoring using, I'm going to call this the guess and check method, because it's a lot faster. Some of the other methods online, they work, and there's actually proofs behind why they work. And I actually used to use a lot of those when I used to teach this in the past, but they're not as quick. And the other math teachers want you guys to speed up. So I'm going to stick with this guess and check method. I really hope you can work your way into this guess and check method if you're trying to use some other method. I don't think photomath is going to be much help with this guess and check method. Um, I think they use the AC method. I don't even know if they call it that on there, but I saw some of your work and I'm pretty sure it's coming from photomath. But try to use this guess and check method because eventually it will speed you up. All right, so here is my factored form for this one. So again, first, 4x squared, last, 9. The outside and the inside need to add to 15x. So 12x plus 3x is 15x. That's why I know that this is the factored form. All right, number 3 I did already, so you can watch my other video if you want to see me do this one. Same as number 5. So let's go for number 4. So I'm going to take out the greatest common factor. Well, this is just a 2. So the only possibility would be a 2. So are the other terms divisible by 2? Yeah. So let's take out a 2. What remains is a 3k squared minus k minus 24. When I go to factor this one's nice because there's a prime for my leading coefficient, so it has to be 3k and k. There's no other possibility because these have to be whole numbers. So 3k times k, that's the only way I'm getting 3k squared. 24, not as nice. We need two numbers that multiply to 24. There are different possibilities. You could do to negative 24. You could try 1 and negative 24. You could try negative 1 and positive 24, positive 3 and negative 8, negative 3 and positive 8. I mean, there's a lot of possibilities here. And some of you are going to have to sit there and try a whole bunch. I saw some of your assignments, and some of you tried, I mean, 5, 10 possibilities. Sometimes that happens. But like I said, the more you practice these, the faster you're going to be able to start to rule some of those out. So let's give this a try. So I need two numbers that multiply to 24. So let me just think. If it was 12 and 2, let's go with a positive 12 and a negative 2. Well, that's not going to be any good because I'd get on the outside, I'd get negative 6k. On the inside, I get positive 12k, but I need a negative middle term. So I need the larger of those two values to be negative. So let's say if I put a negative 12 over here and a positive 2 in the middle, but then I'm going to get a negative 36k, and it's not going to add up enough to give me that negative k. So 12 and 2 do not work. So let's try another one. Let's go with, how about 8 and 3? If I try a negative 8 and a positive 3, I get a 9k on the outside, and then an 8k on the inside, and that is not going to add to a negative k. So let's try another possibility. Let's go with a positive 8, and negative 3. A positive 8 and a negative 3, I'd get a negative 9k on the outside. I'd get a positive 8k on the inside, and that would combine to negative k. So yeah, that works. So this should be a positive 8 and negative 3. And again, if you can't follow that work that I'm just saying out loud, that I'm just doing in my head, that's okay. You can, like I said, you can write down possibilities. Just go through this work, write down some possible combinations, two numbers on the end there that multiply to the last term, and then two possibilities in those first positions that multiply to the first term. Try them out. And until you practice this a lot, it's going to be tough to do what I just did. And some of you, I know, are sitting there going, I can do that too already. And if you can do that already, that is awesome. That's where I'm trying to get everybody at some point. And again, we're going to review this a lot in geometry. And then I'll be teaching geometry next year, by the way, if I didn't tell you that. Excuse me. And then the following year in Algebra 2, you're going to be applying this a lot. All right, so let's keep moving. So number 6, the greatest common factor for this one. So these are some large numbers. This is a little bit tough. So I'm looking at the smallest number. What is 32 divisible by? So I know these are all even. 2 at least goes into them. 32 is also divisible by 4. Does 4 go into the other numbers there? So I'm just going to break out a calculator here. 192 divided by 4, yes. And 216 divided by 4, yes. So it could be a 4 that I could take out. Is 32 divisible by 6? Nope. How about 8? 32 divisible by 8? Yep. Okay, so 192 divisible by 8. And 216 is divisible by 8? Yes. So it might be an 8. Let's try 16. 32 is divisible by 16 is 192. Yes. And how about 216? No. So far we have an 8. And then I tried 16, and then 32 is the only other one. So let's try 192 divided by 32. Yeah. And 216. 216 divided by 32. That does not work. So the greatest common factor on this one is an 8. Alright, so I need to write an 8 on the outside of my parentheses. I'm factoring out the 8. So 32 divided by 8 is 4. So I have 4m squared. So if I multiply those together again, I get this first term. I have a negative. 192 divided by 8, if I divide out that 8, is 24. So this needs to be negative 24m. And then a positive 216, so I need a positive number here. 8 times what gives me 216? In other words, 216 divided by 8 gives me what number? So 216 divided by 8 is 27. Alright, so I need to write 27 here. Alright, so now I've got my trinomial that I'm going to factor. So I have 8 times 2 binomials. The first two have to multiply to 4m squared, and the last two to 27. So I'm going to try, let's go with a 4m here and a single m here, because that multiplies to 4m squared. Two numbers that multiply to 27. Oh, there's going to be a lot of possibilities here. Let's go with, if there was a 1 and 27, that's not going to be a negative 24. A 3 and 9, 3, 4, 12, 9, no. 3, 9, how about 127, that won't give me the 24, so no. So this one does not work. So I'm just thinking all those possibilities in my head. That 4m and m will not allow me to get this middle term, no matter what possibilities I put in those last two positions to get a 27. So I need to try something else. So if 4m and m don't work, the only other possibility is a 2m and a 2m. So I know those are the first two positions. For the other two positions, I'm going to need to think of, again, those numbers that multiply to 27. So I'm going to start thinking, let's say, oh, hang on a second here, we've got a negative in the middle and a positive. I didn't mention this, so I should say this out loud. So if these last two numbers need to multiply to a positive 27, but then they're going to have to combine to give me a negative 24. The only way I'm going to get a positive when I multiply, but a negative when I combine those two terms, is if they're both negatives. So that's another hint. These both need to be negatives. So what times what gives you 27? So like, again, I could try 1 and 27, but then I get 4m squared, the negative 2m, and then negative 25. Yep, so the negative 27 times 2 is 54. Yeah, so that's not going to give me that to negative 24m. I could try a 9 and 3. So if it was 9 and 3, I would get on the outside negative 6m, on the inside negative 18m, negative 6m and 18. Yeah, that works. So 9 and 3. And there we go. That's the factored form. So just to show you again here, this 2m times 2m is 4m squared. The outside 2 would give me a negative 6m. The inside 2 is negative 18m, and negative 6m minus 18m is negative 24m, and the last two, of course, multiply to the positive 27. Alright, for these other ones, let's speed it up a little bit more. I'm going to tell you the greatest common factor. It's a 4. And then if I divide out 4, I get 4k squared minus 9k plus 5. And then I'm going to try my possibilities for my binomials here. The last two are going to multiply to a positive 5, and that's a prime, so I already know what these last two have to be. I can't have any other possibilities other than a 5 and a 1. they have to multiply to a positive, but the middle two terms when I FOIL this out are going to have to be negatives because they combine to a negative 9k. So that tells me that I'm going to need two negatives here. So let's see if it's 4k and k, or is it 2k and 2k. So let me try 4k and k. If it's 4k and k, and multiply those, I get the 4k squared. The outside I get a negative 4k, the inside I get a negative 5k. Yep, that's that middle term. So it's got to be a 4k and k. And there it is. All right, three more to go. So number 8, the greatest common factor is 6. What remains when you factor out a 6 is an r squared plus 4r plus 6. Oops, not 6. What am I doing? Plus 4. 6 times 4 is 24 last time I checked. All right, so now we need to factor this trinomial. Finally, trinomial with smaller numbers. So just a heads up, I am going to be giving you problems more similar to this on your Friday quiz compared to ones like this, or especially like number 5. That's just some huge numbers there. I'm not going to do that to you. They're going to be much smaller numbers. Like number 4 is similar. Number 8 is similar to what you're going to see on Friday. All right, so let's see what we got here. R squared, so the only way you're going to get an R squared is an R times R. The last two has to multiply with 4. And then we're going to have to get that 4r in the middle when we combine the outside and the inside, so it's got to be a 2 and a 2. So first r squared, outside 2r, inside 2r, those will add together to the 4r, and the last two gives you a 4. So this one you can actually write as 6 times the quantity r plus 2 squared. And there is the answer. So this one's a little bit different than what you saw in the notes. You could have circled the previous line as your answer, and I wouldn't have docked your points. I'm just trying to be completely correct. I kind of threw a curveball in here. I didn't realize this would end up like this. That is r plus 2 quantity squared. All right, keep on moving. Let's go to number 9. Greatest common factor on number 9. Let's see, does 6 go into 126? It definitely goes into 12. 126 divided by 6 is 21. Yes, so 6 is my greatest common factor. So 2x squared plus x minus 21. It's got 21, right? 126 divided by 6. Yes, all right. All right, so 6 times, now I need to factor this trinomial. A 2x squared, again, that's a prime, that's nice. I'm going to have a 2x and an x. Multiply those, you get 2x squared. The last two have to multiply to be a negative 21, so they have to multiply to be negative. And then I'm going to need a positive 1x. Well, two numbers that multiply to be negative, I can't have a negative and a negative because those would multiply to be a positive, so that's not going to work. So I'm going to need one negative and one positive. I don't know if the positive goes here and the negative there, or if the positive goes here and the negative here. So I have to try my possibilities. So let's see, if I go with a negative 3 and a 7, negative 3 and a positive 7. Let's try that. Negative 3, positive 7. 2x squared, 14x, and what did I say? Negative 3 and positive 7. I'm starting to get tired here. I got to write these down. 2x squared plus 14x minus 3x minus 21. That is no good. So that one doesn't work. So negative 3, positive 7 doesn't work, but what about positive 3 here and negative 7 there? Let's try that one. Negative 3 here and positive 7 there. Wait, did I just try this? Oh my goodness, I am getting tired. If I didn't just try that, then I'm really getting tired. Let's try this. I think I needed a negative 3 here and a positive 7 there. I am sorry. It's already past midnight. I need to go to bed. All right, let's try this. So we get 2x squared minus 6x plus 7x. Negative 6x plus 7x, that's 1x, so that does not work. Okay, you know what? Yes, I need to go to bed because I just said that doesn't work. What am I talking about? I'm trying to get 1x. I'm sorry. My goodness, I need 1x. I just said negative 6x plus 7x doesn't work. That gives me a 1x. So yes, this does work. This is the factored form. So I guess that one on my second try. maybe third, I don't know, maybe we'll call it 2.5. Let's keep moving. All right, let's go to number 10. So the last one here, so the greatest common factor between all three of these, let's see, 9 goes into 45, does 9 go into 56? No, go into 54, so it's close, but it does not go into there, so 9 doesn't work. We could try 3. 3 goes into 9, 3 goes into 45, and is 56 divisible by 3? I believe so. 56 divided by 3, maybe not. So 3 does not work. So let's try, oh, obviously it doesn't go into 60, there it goes into 60s, 57 is divisible by 3. All right, let's try, I tried 9, I tried 3, so there's nothing. There's no greatest common factor in this one. So let's see, every other problem I believe had a greatest common factor. 4, 6, 2, 2. Yes, every other problem had a greatest common factor except for the very last one. So again, a little bit of a curveball there. It does not have a greatest common factor. So we're going to go right to factoring. Let me break this off here. There we go. So I need to write it as a product of two binomials. The first two have to multiply to 9w squared, so I'm going to try 9w and 1w. The last two have to multiply to 56, so how about a 7 and 8? Try this, you get 9w squared. The outside is going to give me 72 and then another 7w. Yeah, and 72w and a 7w is not going to give me 45w, so that's no good. So let's try a 3w and a 3w in those first two positions with a 7 and an 8. So I'm trying, because of that 9w, that gave me way too many w's. So 9 times 8 was 72, and I only need 45w. So I'm trying the 3w and the 3w, so I don't get as many w's. So 3w times 3w is 9w squared. 3w times 8 is 24w, and then another 21w. Yes, that is 45w when you add those together. And the last two multiplied together gives you a 56. So this is the factored form on number 10. All right, I am going to bed. Have a great night. And now you're probably watching this during the day, so have a great day.